Example 4. Find a polynomial of degree 3 whose zeros are -1, 0, and 5. Now first, I want to underline this degree 3, because in example 5, it's the exact same question except it says degree greater than 3. So just note that difference for now. Okay, so all we're given are zeros, but we know that we can make factors of a function if we're given those zeros. So if we have our function f of x, we'll put a constant a in the front, and we'll talk about that in a second. And we know that if -1 is a zero of the function, then x minus -1, which is x plus 1, would be the corresponding factor. And then if 0 is one of the zeros of the function, then x minus 0, which is just x, will be one of the factors. And then if 5 is a zero of the function, x minus 5 will be the corresponding factor. So our easiest option would be to choose an a value of 1. So let's talk about that. If we choose a equal to 1, that gives us f of x equals x times x plus 1 times x minus 5. So let's look in the calculator. So I enter the function here with an a value of 1. I'll just peek in at the window here. On the x-axis, I'm going from -10 to 10 with a scale of 1. And on the y-axis, I'm going from -25 to 3 with a scale of 3. Again, not the only window that would work here, but this will give us a good idea of the shape. So if we go to the graph, we can see that the graph crosses the x-axis at -1, 0, and 5, which makes sense since the zeros of our function are -1, 0, and 5. So this definitely would work. Now let's go in and change the a value to a -1. So we can imagine what happens when we multiply a negative out in front of a function. And if we look, it's the same shape, but it's reflected about the x-axis. But all that's important is that the x-intercepts are still -1, 0, and 5. So it turns out in this case that a value, a, can actually be any real number. And this is because there's no picture given. No picture given to indicate the shape. So as long as we have those three factors, x, x plus 1, and x minus 5, it would be a possible polynomial function. Now note, this is degree 3. If we expanded this out, if we multiply this out, we have 1 degree from this x, 1 degree from this x, and 1 degree from this x. So this would be a degree 3 polynomial. And another way to think of this is each factor gives you a degree. So when I made my factor x, that gave me a degree. When I made my factor x plus 1, that gave me another degree. And I made my factor x minus 5, that gave me another degree. So if you want to make a little sketch in your notes here, again, all that's important is the general shape and the x-intercepts. So in this case, when we chose an a value of 1, if you remember our x-intercepts are all that matters here. We got -1, 0, and 5. So when the a value is 1, it looks something like this. So this is 5, 0, 0, 0, and -1, 0. So this is when a was 1. And then if you remember when we made a a -1, it reflected it. So the shape was something like this. So this is when a is -1, excuse me, but all that matters is that it has the zeros -1, 0, and 5. Okay, now I'm going to go right into example 5 because it's the exact same question. Find a polynomial with zeros -1, 0, and 5, except this time we want a degree greater than 3. So we want a degree 4 or a degree 5 or etc. Okay, so let's talk about a degree 4. So we know that this function, we'll put our a out in the front, it has to have the factors x, because the 0 of 0. It has to have an x plus 1 because of the 0, negative 1. And it has to have an x minus 5 because of the 0, 5. But we know if we just write x, x plus 1, and x minus 5, that's only degree 3. So we can increase the degree by increasing the powers. So we could make this an x squared, for instance. Or we could leave the x alone, and we could square the x plus 1. Oh, whoops. Leave the x alone and square the x plus 1. So both of these, if you look at the degree, here's 2. Add one more from here and one more from here, that's degree 4. Or this one, here's x to the first, that's 1. X plus 1 squared, if you take that x and square it, that gives you 2 more, and then here's your 4th degree. So there's lots of different options here. We could have f of x equals a times x plus 1, and we could square the x minus 5. And then there's all the different combinations of a here. So a long list of possibilities, infinite list really. Now if we look at degree 5, again it says any degree greater than 3, so we'll just look at 4 and 5 for example. So I know my function, here's my constant a, it has to have the factors x, x plus 1, and x minus 5. So now I need their exponents, their powers, to add up to 5. So again, lots of different options. I could cube the x, and then that would give me degree 3 plus 1 here, which would give me degree 5. Or I could square the x and square the x plus 1 and leave the x minus 5 alone. Or there's many others, as long as their exponents add up to that degree greater than 3. So to summarize, we said up at the top here, each factor of the polynomial will give you a degree. So if you want degree 3, you're going to have 3 factors. If you want degree 4, you'll have the exponents adding up to 4. So although I don't have 4 factors, I have 3 factors here, but one of the exponents is a 2. So it's like this factor counts twice. Or if I squared the x plus 1, that means this factor counts twice. And this is actually called multiplicity, which we will talk about shortly in the next section.